Alright guys, so this is 4.6 in the textbook, or 4.5 of our lessons. Okay, and this is all on combinations. Or 4.6, 4.6, depending on how you look at it. Okay, so the last lesson was all about permutations. This is all now about combinations. So permutations were all about arrangements that you could be made where the order of things mattered, right? Like the first example I did for permutations were the flags on the boat. The arrangement that you made with those flags stood for something. So order mattered there. Here with combinations, order does not matter. All right, so this is arrangements where order of the objects does not matter. Okay, so for example, if you were choosing, let's say, people for a committee and there's a president, vice president, treasurer, or something like that, order matters, right? Who you pick as president and then who else you pick as vice president, that matters. Whereas if you're picking just 5 people to work on something, like a group of 5 people to be partners for a school presentation, the order that you pick them in doesn't matter. So because when you get into that and the order of things doesn't matter, there's more results that can occur. All right. Now combinations is a lot like permutations. There's a formula where it's just NCR on your calculator. It's right beside the NPR button typically, or the probability button on your Texas Instrument. And N is still total number, and R is still the number you want, number or amount you want. But here the formula is just a little bit different. It's n factorial n minus r factorial, just like permutations, but then you also multiply it again by r factorial. Okay, now that's not the same as NPR. It's a little bit different. So your numbers will be different here. Another way that they show it, so like you see NCR on your calculator, sometimes the textbook will even write it like this, N over R, and have brackets around it. It's the same thing. It's just another way of writing it. So they're the same thing there, okay? So you're just going to take, the trick here is just figuring out what to punch into your calculator. And it can be a little tricky at first. But people tend to like combinations better. You just need to remember with combinations, things can be moved around and the order that you pick things out at doesn't matter. Okay? So we'll go through, I'll show you tips to look for here, and we're going to spend some time practicing some of this stuff between permutations and combinations. So the first question here says, a group of 5 students is to be selected from a class of 35 students. How many different groups can be selected? Now when you're picking a group of people, and it doesn't say like there's a president or there's titles that go along with it, then the order doesn't matter. So this is a combination. So now it's just 35 C5 in your calculator. Oh no, where's my calculator? There we go. Make sure you guys are trying this, just so you're punching things in. So there's actually 32,400, or sorry, 342,000. 324,632 different committees you can make up, or groups of 5 from 35 students. Okay, so these are big numbers. That's why having a calculator is very important. So now the next example here is you have Lisa, Gwen, and Al. They're all BFFs, and they want to be on the same group. So how many possible groups include all 3 of these students? So what you need to think of is, okay, you've already picked 3 students. You have 5 spots. 1, 2, 3, 4, 5. The first 3 we know are Lisa, Gwen, and Al. So there's only one way to pick all 3 of those. Now these last 2 here, it's a combination because the order doesn't matter. I've already picked 3 students, right? Lisa, Gwen, and Al. So there are 35 students in total. Take away 3, so there's 32 students left. And I'm choosing 2 of them. So then you just go 32 C2. $496. Okay. All right. Now, let's move on to the next one. Okay, standard deck of cards. You guys are going to have to get used to a deck of cards because they make up a lot of my questions. Standard deck of 2 has 52 cards. There's 13, or half the deck is red, half the deck is black. There are 2 suits of red cards, hearts and diamonds. There's 13 of each. And so there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Alright, and it says it right here, 13 cards and 4 different suits. And it goes from king, queen, jack. Those are your face cards. Then it goes 10 down to ace. Here, ace is low. King, queen, jack are your face cards. So there's 3 face cards per suit times 4 suits. There's 12 face cards in total. These are things you're going to get used to. I'll have a printout for you guys on the website. Just click the link and you can see what a deck of cards looks like, and you can count them out too. Alright, so what we want to know is how many different 5-card hands can be formed with only red cards. Okay, so remember I said half the deck is red cards. So you take a 52, if you divide that by 2, you get 26. 26 red cards in total. So that's how many cards I'm working with. So it's going to be 26, and I'm choosing 5. All right, now, card questions. You're going to see a lot of them. They're always, 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 always combinations. They're never permutations. And the reason is think about it. When you deal out cards and you're playing a card game, you pick those cards up and you move them around. The order you're dealt your cards doesn't matter. You always shuffle the cards in your hand around to lay them out how you want them to work. All right? You never play card games. Well, rarely do you play card games where you have to play the order that you've been given. So that's why card questions are always combinations. And then once you know that, you just go in, 26C5, hit enter. 65,780 different ways that can happen. Okay? Now, how many different 5-card hands can be formed containing exactly 3 black cards? Okay, so if you're being dealt 3 black cards, that also means you're being dealt 2 red cards. So deal with what you've been asked for first, and then work out the rest. So you want 3 black cards. So you're going to go, it's easier for me to write, for your black cards, 26C3. Now you're being dealt 5 cards, so you also have to account that you're going to get 2 more cards, and those are going to be your red cards. So you're going to be dealt out of the 26 red, 2 of them. So what that means now is you take both these amounts and you times them together. That's just like the fundamental theorem of counting that we talked about before. So you work this all out. I recommend trying to do this all at once on your calculator. So you go 26C3, enter, times 26 C2, you should get 845,000 even. Okay, so there's lots of permutation or combinations of cards that you can get there. Okay, we'll do more with cards coming up. We're going to be doing a lot of this, so just try to get used to it a little bit here. We're going to take it a little bit slow. This will be a 2-lesson type thing. Okay, how many 5-person committees now can be formed from a group of 6 women and 4 men under each of the following conditions? Okay, so we're going to put some stipulations in now, and we'll have to figure out how those work. So the probability of no conditions. So we just want the probability of 5 people. So we know we have 10 people in total. Because it's committee with no titles or anything, it's just going to be 10C5. Oh, 252, not 256, sorry. All right, so there's 252 different committees you can make with 10 people, and you want 5 of them. Now, the next one, these are where you get combinations now. So probability of 3 women. If you have 3 women, that means, and you're going to have 2 men, right? So now, so it's going to be, so let's deal with the women first. 6C3 times 4C2. Now, if you look here, this kind of works out. Your totals out front, if you look here at my totals out front, they add up to the total amount of people that I have to pick from, right? 4 plus 6 is 10, and I have 10 people to choose from. And if you look at your back numbers, they add up to 5, the amount that I want. All right, so that's always kind of like a check that you could do. Next one, there must be exactly 4 men. So probability of 4 men and 1 woman. So that's going to be 4C4 times 6C1. Again, 4 plus 6 is 10, 4 plus 1 is 5. Oh, I never figured out the total for this first one. We'll go back there. I'll finish this one up first. So 4C4, that's going to be 1 times 6C1. So there's 6 ways you can do that. Right? Because there's how many ways can you choose 4 guys out of 4? 1 way. You guys come with me. All right, now for this one up here that I forgot to do, let's quickly go back. 6C3. If you want, I'll even write it out this time. Maybe that'll help you guys. 6C3 is 120 times 4C2 is 6. You work that out. 720 different ways that can happen. Okay. Now, there can be no men picked. So probability of 0 men and 5 women. All right, cool. So for the guys, 4C0 times 6C5. So you work that out. I'll show you all my numbers here. 4C0, that's just 1. There's only 1 way to pick no people. I don't want any of you. Boom, done. Right? And then 6 times 6, and I'm choosing 5. 6 ways to do that. So there's 6 ways for that to occur too. Now, this last example, there are 4 or more men. That's a typo. Ignore that one. Okay. So that's the lesson here. Your guys' assignment today, where did I write that down, is on page 280. want you to do 4 to 8. Do 10. Yeah, and that's your assignment for today. That's a 10, not a 16. Okay? Oh, put 3 on there too. Sorry, guys. All right, there you guys go. Enjoy.